Alright, admin of code, day 14, part 2. So essentially, after reading this over, so in the first one we were masking the input, or we were masking the value bit. So we were applying the mask to the value, and then you were just storing the result in this single memory address. This one, instead of applying to the value, you're applying it to the address value. And then you're treating these x's as floats. So you could potentially, these could float to, like this one mask, these x's can float between 0 and 1, and so you have to generate all possible permutations of these. So these two x's will generate 4 possible address values, and then you store this 100 in that. You ignore this memory array value, and then instead you apply the mask to it, and then you store this value in all of those 4 values. So what I did for part 1, I haven't made a video for this yet, but I will. I have this bit mask, and then I have an apply to it, and then it just takes if the value is equal to x, then you just ignore it. Otherwise, you set it to the input. So I think what I'll do is create a copy of this class and then make a bitmask part 2. I'm going to call it v2 to be all fancy and concise. So bitmask v2, it's going to have the same deal where it's going to have the input value is going to be a string. This is not going to be an ignore character though. It's going to be, I'm going to call it the float char. And then we want to apply it to an input. And I can keep this same contract where this input will be a long, and then this is going to be the same deal where it converts it, and then it pads the start of it with zeros. So here's the meat of this. Instead of returning a long, we want this to always return a list of long, since there's a lot of possible values if it's going to be floating. And then, so we're going to need to store this list of possible values somewhere. So this output is going to actually be a list, a mutable list of nothing, of long. Actually, for now, I'm going to make it a string. Mutable list of string, and then I'm gonna have it. I'm gonna have to map it dot to long, and that'll be it. So we store the. So this will be what I'm thinking is like. We're gonna go through. If we encounter a 0, then just ignore it, right? You just do I think it's. If the bit mask is 0, corresponding memory bit is unchanged. Otherwise, you override it. So there's 3 different cases here. And I think in the X case, what we'll do is we'll store a list of possible outputs, and then when we encounter the float character, we're going to have to duplicate whatever we have in this list, and then append 0 to half of them, and then 1 to the other, to the duplicate set. I'm not sure if that's the most efficient way to do things, but ultimately it's going to give us this output. So we have 3 different cases here. So I'm going to use a when statement. A when is like a switch statement in Kotlin. So I'm going to say when value at I. So we have 3 cases here. Oops. We have the 0 case, and this is going to be a character. In the 0 case, we want to go. We want to take the output equals output dot map. And then we're going to concatenate it. So it's going to be it plus and then this is gonna be just the value. Let's see, this is gonna be the input at I, because we're not gonna touch it. It says leave it unchanged. And I guess, so yeah, I want to append this to this string. I think I need to initialize this with something just empty here. Mutable list of, what is this complaining? Oh, I see. Here we go. That's why the compiler was confused, because we were telling it that it was a string, but we were giving it a list. Okay, so now we have this output.map. And then I think I do need to keep this as a mutable list. This is maybe not the most efficient way to... Can I do like is there a way to do like a compute? Because I basically want to remap these to, I want to take each of these and then append this value. I wonder if I could just do... I don't know. I think I'll leave it for now, and if there's a way to just overwrite that value, then I will. I might just do a... yeah, I'm just going to write this kind of brute forcey for now. I was thinking of maybe writing a function that would append to the output. I think I will. I'm going to make a private fun append output, and this will basically take this input character, and this is a char, and then it's just going to go through everything in the output and then append that character to the end of each of those. And then we're going to also need to, I don't know, I think I might make output just to save memory here, I'm going to make output. No, I think I'm just going to, I'm going to have output is going to be this mutable list of string. I'm going to just use a for loop for I in output dot indices. Output at I plus equals char. Can I do that? Yeah. Yeah, so this will just go through and append to each of those, and then we can pass it this list, and then we can reuse this when we make a duplicate of that. So I'm going to just do append output, and then we're going pass in the input at I, and then the output. And then when it's 1, we want to append 1, right? And then here's our special case when it's the float char. This is when we want to make a copy of the output, and then we want to apply 0. We want to apply 0 to everything that's in there. Make a copy, or like make a copy. One of the copies is going to have 1s added to the end, and then the other copy is going to have 0s. So this is going to create a copy of this as a mutable list. I'm going to have 1s here, and then 1s dot, I'm going to have it go append output. We're going to say 1 to the 1s, and then we're going to append 0 to the current output. And then we're going to go output.add all. And then we're going to add the 1s to it. So that basically creates, we're taking everything in the output, we're duplicating it, adding 1s to it, and then adding it back into the output. So let's test that out. I'm going to create a test here for that bit mask. Okay, so we have this. It has two different x's, so we should get an output of 4. Bit mask v2, and then we're going to pass in this value here, mask.apply, and then this input is going to be 42. And then I'm going to say results plural, and then we're expecting, since there's 2 x's, we're expecting 4, a count of 4. So results.size should be 4. And we want to check if it contains all of these. We want 26, 27, 58, 59. And then we want that to be true. So I'm going to set a breakpoint here. I just want to take a look at what the results are. It is a nice sunny day here in Portland. Okay, so the results, it is indeed 4. Okay, and the interesting thing is it didn't really, did it not, oh, I think I know what happened. We have to pass in a radix value of 2 here to tell it that we're mapping it, but it's binary. So that's the problem. So let's do this. There we go. Okay. And then now let's just try out, I'm going to make a day 14 v2 test. And then I just need to rewrite this to be a bitmask v2. And then we also we need to rewrite the solver, so we're not applying the mask to the command, the value of the command, we're applying it to the address. So we need to rewrite part of this solver here. And then first I'm going to make sure to change this sum to be 208 is what we're expecting from this example, right? Assuming that this is the same. Consider the following program. Let's just double check that this is the same. So we're setting, oops. Oh no, this is different. I'm going to make a new file, tay14 part2 example.txt, and then I'm just going to pass in this program here. Make a copy of this, and then we're going to pass in this as the input. So we're solving this, then the solve is going to be, so we still have this memory, which is a map of long. If the mask is this, and then otherwise we parse the command, and then we want to just get a val addresses is going to be the list of memory addresses that we want to write. So that's going to be we're going to apply the mask to the command.location, and that's going to give us the addresses. This is, we have to assert that this is not null because we've set up here that it's nullable. And then now that we have those addresses, then we go addresses dot for each, and then we want to write the memory. Memory at it, which is the address, equals the command dot value. So this is this case where we're writing 100 to all 4 of these values. And then everything else should be the same. We're going to sum up the memory values that are there. So let's try it out, see what we get. Sure enough, it worked. So let's try to solve part 2 with this. We get this massive number here. And let's submit it. Sweet, that's awesome. This was fast. This was easier than I was expecting. So thank you for watching, and I will see you in the next one.